Hey everyone, and welcome back to the Web Solution Master. Today, we're rediving deep into a topic that's absolutely crucial for any serious developer: mastering security in your Next.js applications. Building cool features is fun, but ensuring your app is a fortress against attacks. That's what separates the pros from the amateurs. So, if you're ready to level up your Next.js skills and build truly robust, secure applications, you've come to the right place. We're going to cover everything from locking down your API routes to protecting against common vulnerabilities. Let's get started. First up, let's talk about the backbone of many Next.js apps: API routes. These are the gateways to your server-side logic and data. Leaving them unprotected is like leaving your front door wide open. The first layer of defense is authentication. You need to verify who is making the request. Is it a legitimate logged-in user? Or is it an unauthenticated stranger? There are many ways to handle this. For traditional applications, you might use session-based authentication with cookies. For modern headless apps, JWTs or JSON web tokens are a popular choice. Libraries like Next.js make this incredibly easy. It abstracts away a ton of boilerplate and supports various providers like Google, GitHub, and email password. When a request comes into your API route, your first step should always be to check for a valid session or token. If it's not there, or if it's invalid, you immediately send back a 401 unauthorized response. No entry. But authentication is only half the story. Just because a user is logged in doesn't mean they should have access to everything. This is where authorization comes in. Authorization is about permissions. What is this specific user allowed to do? For example, an admin user might be able to delete data, while a regular user can only read it. Inside your API route, after you've authenticated the user, you need to check their role or permissions. You might have this information stored in your database and attached to their session object. So, you'd have a check like if user. Role is not admin, then return a 403 forbidden error. This ensures that even authenticated users can't perform actions they're not supposed to. By combining strong authentication and granular authorization, you create a powerful defense for your API routes, ensuring only the right people can access and manipulate your data. Now let us move on to one of the oldest and most dangerous threats on the web: malicious user input. Should always treat any data coming from the client side as untrustworthy. Never assume it's safe. Two of the most common attacks that exploit user input are cross-site scripting, or XSS, and SQL injection. XSS happens when an attacker injects a malicious script into your application, which then gets executed in another user's browser. Imagine a comment section where someone posts a script that steals other users' session cookies. To prevent this, you must sanitize all user inputs before you render them on a page. This means escaping any HTML characters, so a script tag becomes an LT script in GT, which the browser will display as text instead of executing. Libraries like Do and Purify are excellent for this. Will strip out any dangerous HTML and attributes, leaving only safe, clean content. When you're displaying user-generated content in your React components, be very careful with the dangerously set in your HTML prop. As its name suggests, it's dangerous. To only use it if you are absolutely certain the HTML you're passing has been thoroughly sanitized. The other major threat is SQL injection. This occurs when an attacker manipulates an input field to trick your database into running unintended commands. For example, they might turn a simple username lookup into a command that drops your entire user table. It sounds scary, and it is. The key to preventing this is to never, ever construct SQL queries by directly concatenating strings with user input. Instead, you must use parameterized queries, also known as prepared statements. Pretty much every modern database library or ORM, like Prisma or Drizzle, does this for you by default. You use a method like Prisma user, find unique where, email, user input. Prisma ensures that user input is treated as a value, not as part of the SQL command itself. This effectively neutralizes the threat of SQL injection. Takeaway here is simple: sanitize for XSS on the front end when rendering, and use parameterized queries on the back end when interacting with your database. Don't trust your user's input, ever. Next, let's talk about secrets. Your application has sensitive information it needs to function: API keys, database credentials, secret keys for signing tokens. These should never, ever be hard-coded into your source code. If you commit them to a public Git repository, they will be found by bots within minutes. This is a rookie mistake that can have devastating consequences. The proper way to handle this in Next.js is by using environment variables. You'll create a file named env-local in the root of your project. This file is where you'll store all your secrets in a simple key equals value format. For example, database_URL equals your _database_connection_string. Crucially, you must add env local to your gitignore file. This prevents it from ever being committed to version control in your Next.js code. You can access these variables on the server side via process env database_URL. Now, what about variables you need on the client side, like a public API key for a service like Google Maps? You can expose environment variables to the browser by prefixing them with next_public_. For example, next_public_analytics_IDYOUR_ID. This variable will then be available in your browser-side code as process env. Next_public_analytics_ID. But remember, anything prefixed with next_public_ is, as the name implies, public. Anyone can see it by viewing your site's source code. So never, ever put any secrets in a next_public_ variable. For your production environment, your hosting provider, whether it's Vercel, Netlify, or AWS will, have a secure way for you to set these environment variables directly in their Platform S dashboard. This keeps your secrets safe and separate from your codebase, which is exactly where they should be. Another fundamental aspect of web security is encrypting data in transit. When a user sends information from their browser to your server, or vice versa, it travels across the public internet. Without encryption, anyone snooping on the network, a man in the middle, could intercept and read that data. This could include passwords, personal information, or session cookies. The solution is HTTPS. HTTPS encrypts the connection between the client and the server using TLS/SL protocols. This ensures that even if someone intercepts the data, it's just a jumble of unreadable gibberish. In today's web, there is no excuse for not using HTTP's. Browsers will flag sites using plain HTTP as not secure, which will scare away users. Fortunately, modern hosting platforms like Vercel make this incredibly simple. When you deploy your Next.js application to Vercel, it automatically provisions and renews an SSL certificate for your custom domain, enabling HTTPs by default. There's really no extra work you need to do. If you're managing your own server, you can get free certificates from services like Let's Encrypt and configure your web server like in Ginx or Apache to use them. Bottom line is, always use HTTPS. It's a non-negotiable standard for any modern application. Finally, let us discuss a security practice that is often overlooked but is critically important: keeping your dependencies up to date. Your Next.js application relies on a whole ecosystem of NPM packages. These are a mix of Next.js itself, React, and various other libraries you've installed. The problem is that vulnerabilities are constantly being discovered in these packages. A security hole in one of your dependencies is a security hole in your application. Hackers actively scan for applications using outdated packages with known vulnerabilities. This is low-hanging fruit for them. The good news is that the open source community is usually very quick to patch these vulnerabilities. All you have to do is update your packages. You should make it a regular habit to run npm audit in your project. This command will scan your dependencies and report any known vulnerabilities, often suggesting a command to fix them like npm audit fix. For more complex dependency issues, you might need to manually update packages in your package JSON file. Tools like GitHub's Dependabot can automate this process for you. It will automatically create pull requests to update your dependencies as soon as new versions are released or vulnerabilities are found. By regularly updating your packages, you're essentially patching security holes before they can be exploited. It's one of the easiest and most effective things you can do to maintain the long-term security of your application. So, to recap our journey into Next.js security. First, lock down your API routes with robust authentication and authorization. Second, always sanitize user input to prevent XSS and use parameterized queries to stop SQL injection. Third, keep your secrets out of your code and manage them securely using environment variables. Fourth, Always use HTTPS to encrypt data in transit. And fifth, make regular dependency updates a non-negotiable part of your development workflow. By consistently applying these 5 principles, you'll be building Next.js applications that are not just feature-rich and performant, but also resilient and secure against common threats. Security isn't a one-time checklist. It's an ongoing process and a mindset. Building with security in mind from the very beginning will save you from major headaches down the road. Thank you so much for watching. Hope you found these tips helpful for hardening your Next.js projects. If you have any other security tips or questions, drop them in the comments below. Let's learn from each other. If you enjoyed this video, please give it a thumbs up and consider subscribing for more content on modern web development. Stay safe and happy coding.